Imagine a world where the resources in and around your building can be harnessed to power your building, reducing both costs and greenhouse gas emissions, where the heat that typically dissipates into the air, the wind that passes by practically unnoticed, and the food scraps that fill your compost or garbage can all be utilized to create sustainable energy. This is not some distant future. This technology exists today, waiting to transform how we power our spaces. And we are not just talking about incremental savings. We are talking about a fundamental shift, one that turns our buildings from energy consumers into energy producers. The financial impact is substantial, as is the environmental one. For every kilowatt hour of energy created from recovered waste, that is one less unit of carbon entering our atmosphere. What we are about to share with you today will transform the way you view the untapped potential of your buildings and show you a path towards a more sustainable and cost-effective future, one where even what we throw away becomes valuable. I'm Amy Wolf with New Seasons Market. This is Joseph Sater with Fry's Food and Drug, Sarah Brannon with Albertsons Seattle and Hagen, Mackenzie Wiseman with Winco Foods, and Kelsey Atkinson with New Leaf Community Markets and Lazy Acres Natural Market. And together, we are the Energy Revolutionaries. So let's not just imagine a better world. Let's build it. At the end of our presentation today, we will ask you to invest in renewable energy sources to power your buildings. But before we get there, let us take you through the journey we will be embarking on together today. As a team, we began our research into 3 problems. These problems are increasing greenhouse gas emission regulations, rising utility costs, and the instability of our current electrical grid. We found solutions from anaerobic digesters that turn food waste into electricity, to thermoelectric energy recovery systems, to renewable microgrids that combine wind, solar, and other alternative energy sources to allow you to be completely independent from the traditional electrical grid. We are also going to take you through the financial implications and the return on investment. So we're going to go through the problems, the solutions, and the financial impact. Let's start with the problems. Greenhouse gas emission regulation is shifting on the national level. However, many states, especially on the east and west coasts of the country, they have their own state-level comprehensive greenhouse gas emission regulations. As most of you know, California is often at the forefront of environmental policy, and other states tend to follow in California's footsteps. So let's dig into the recently passed State Bill 253. State Bill 253 applies to all businesses that operate in the state of California, either publicly or privately held, with revenues of $1 billion or more. Starting in 2026, these businesses will have to report on their Scope 1 and 2 greenhouse gas emissions. Scope 1 are direct emissions from the operation of the business. Scope 2 are indirect emissions from purchased energy, such as electricity. Beginning in 2027, these businesses will have to report on their Scope 3 emissions. Scope 3 are indirect emissions from the supply chain, so both upstream and downstream from a business. Failure to comply with State Bill 253 could result in a $500,000 fine per year, and also open a business up to litigation. But beyond that, these reports are publicly available, so a business risks being called out by environmentalist and activist groups and facing serious backlash in the court of public opinion. So let's move into rising utility costs.
I first want to start off with the real-world experience. A regional grocery chain spent $50 million in utility costs alone for the fiscal year of 2024. That equated to about $600,000 per store. Let that sink in. Utility costs have been on the rise over the last decade, and will continue to rise over the next 5 years, up 10%. Let's face it, utility costs are rising, but it's also becoming unreliable as well. There are 4 main reasons as to why this is transpiring. First off, the demand in electrification, databases, electrical vehicles, and AI are driving costs up. Interesting fact, databases alone will constitute 50% of the total US consumption by 2028. Number 2, our aging infrastructure. Our aging infrastructure is outdated and inefficient. Mexico happens to be the #1 importer for transformers across the United States. However, due to political tension, tariffs, and shortages, it is becoming increasingly challenging to update and modernize our grids today. Third, inflation and geopolitical turmoil. With trade wars and conflicts around the globe, it is becoming challenging to import and export amongst each other, causing prices to rise. And finally, extreme weather. Mother Nature is beautiful, but she's also very unpredictable. And during natural disasters, it is detrimentally damaging our grid today. Let's face it, our grid is under serious strain, and without any modernization, it will continue to be fragile. The map that you see before me is from the North American Electrical Reliability Corporation. Their sole purpose and job function is to ensure that energy demands are being met across all regions. However, this map is showing something different. They use a simple color code system to signify the risk tier that regions are facing. For example, all the red regions on this board are at a high risk, meaning that the demand could be shut off at any time. Orange is at an elevated risk, meaning that power is being met across the board. However, with the smallest influx, it could be turned off at any moment. And finally, the blue regions. These are the low-level safe zones. But my question is to you, how long are these actually safe for? With just demand and electrification in itself, these areas are subjected to change in time. Let's face it, our grid was not built for the world that we live in today. And if we cannot cascade energy safely and reliably across the board, we are in a world of turmoil. And if that doesn't hit home with anyone in this audience, let me put it in this context for you. Every single grocer in this audience will be affected. Every single CPG company will be affected. And essentially, every single supplier will be affected some way or somehow. No power means stalled deliveries. No power means spoiled goods. No power means halt in production. And essentially, no power means loss of sales for all of us. So I implore this audience today, rather than wait for somebody to come and fix the imminent future, that we now must take matters into our own hands and do something about it. And my team and I have the solutions on just how to. Let's start with the first solution.
1/3 of food produced is wasted. Think about that. That equates to 600 to 700 pounds or $2,000 to $3,000 per day per store. But we told you we were going to talk about the solutions, so why are we talking about food waste? Food waste can power your buildings, which leads to our first solution. An anaerobic digester takes organic material, like food waste, converts it into fuel to lower your energy costs and boost your bottom line. Items that can be put in an anaerobic digester: produce coal, meat scraps, expired product, damaged product, returned product that's not safe to return back to shelves. Any type of food item that would be going in the trash could go into this anaerobic digester. Now, we are seeing some in our industry today are using an anaerobic digester on a large format, We are proposing today a smaller footprint store, or smaller footprint location. Technology is rapidly advancing, and an anaerobic digester is becoming increasingly small. Behind me is a single store in Portugal. Their anaerobic digester is housed in a single shipping container on site. Because it's on site, there's no need for food waste disposal fees, and this is especially important in the state of California when food waste disposal fees have increased each and every one of the 10 years, 20% each of those years. The cost to properly dispose of food waste now is $250 per ton in the state of California. You can also, in the smaller scale anaerobic digester, you can put in fat, oil, and grease from your deli fryer. We recently, as a team, met with CAB Energy, the makers of the small scale anaerobic digester, for the store in Portugal. Let's see how it works.
Made an appliance that every building should have, and which every island could use, and which is able to create power for millions, anywhere in the world. Load your food waste into the FlexiBuster every day, and the system does the rest. The software manages the flow of your waste through the mouth, into the buffer tank to wait until the bacteria are hungry, and finally into the digester, where the bacteria eat it. This process makes biogas, fertilizer, and water from your waste. You can use the biogas to create electricity, heating, and cooling. The FlexiBuster can convert between 200 and 1,000 tons of waste per year into fuel, eliminating harmful emissions and odors in the process.
Another advantage with the smaller scale anaerobic digester is you can put the product with the packaging on. This is a game changer. As a retailer myself, I've personally had to throw away thousands of dollars worth of product after a major power outage, and I can imagine many of you in the audience have had to do the same unfortunate situation. With an anaerobic digester, you can take that food waste, turn it into fuel, lower your energy cost, and boost your bottom line. Now let's look at our second solution, an emerging breakthrough technology.
As Vice President of the bakery at Winco Foods, I've often wondered how much of the energy is wasted in our bakery ovens. And in our research, we found that 30% of the heat generated in those ovens actually makes it into the finished product. The rest of it is lost, sent up and out of the buildings through the exhaust system. And this is a perfect example of our second solution, harnessing thermoelectric energy throughout our buildings. Thermoelectric energy and the heat necessary to generate this potential energy source happens throughout our building, in many functions throughout our buildings, including the HVAC system, the refrigeration system, our production equipment, and our food service departments. Recently, a study by Penn State University was able to increase the efficiency in thermoelectric generators to equal that of solar panels, which is a major step forward for this technology. So let's move on to what you see behind me, which is a pizza oven with a thermoelectric generator attached to the top of it. That thermoelectric generator is capturing the wasted heat and using it to power the lights and the register in the pizza restaurant, as well as effectively eliminating the need for a hot water heater. This technology has improved significantly over the past couple of years, and this is a significant long-term investment, for the pizza restaurant. And while thermoelectric energy is an exciting emerging technology, our third solution, which is renewable microgrids, is key to the future. Renewable microgrids sounds complex, but it's really a simple, straightforward solution. To build a renewable microgrid, you're going to use wind and solar power, which we recognize many of you are already familiar with. We're also going to add in an anaerobic digester and thermoelectric generators, which we recognize that we've already talked about today. And that's going to allow you to fill in the gaps. And then you need an energy storage system, which is just this collection of big batteries that you're going to use that to store the excess energy that you're going to create in your microgrid. And then finally, you need a smart controller, which is essentially just a big on-off switch. And you're going to use that switch to tell the system whether to be on the grid or off. And you're going to operate your building completely independent of the power grid. And there are many benefits to being able to operate your building completely independent of that traditional utility grid, including having your doors open and your lights on in the event of rolling blackouts, power shortages, power outages, and natural disasters, which we've already seen today, an example of the wildfires that devastated Southern California this past January. This technology is currently being used in many different industries today, including in hospitals and military bases and in the agriculture industry. But it's also being used by many retailers, including Whole Foods. Whole Foods is using this technology in Brooklyn, New York. And if they can use a microgrid in Brooklyn, what are you waiting for?
Let's take a moment to look at the financial impact of some of the solutions we've outlined today. But first, I want to start with the reduction of utility costs. Some of these technologies alone are reducing utility bills anywhere from 30, 50, to 100%. Remember that regional grocery mentioned earlier in the presentation? The one that spent $50 million on utilities in the fiscal year of 2024? Imagine if they cut that in half. What would you do with an extra $25 million? I know I could do a whole lot. Looking into the financial investment side of things, on-site small-scale anaerobic digesters have an initial investment of approximately $230,000 and a return in 1.5 years, which is truly remarkable for any industry. When we look at renewable microgrids, we see an initial net investment that our team estimates of approximately $780,000 and a return in just under 4 years. And while we know that might seem a little hefty off the bat, there's no way to truly quantify what it means to have your lights on and your doors open when your neighbors and competitors are forced to shut down due to power shortages. But what we can quantify is what happens to your business when the power does go out and the clock starts ticking. In just 24 hours, some of the losses that you're nearly guaranteed to incur include a loss of perishable goods due to your refrigeration and your freezer going out. You're also going to see a loss of sales due to product not leaving the shelves in customers' hand or getting on delivery trucks to be delivered to retailers. We're also looking at, lost sales, recovery labor cost due to having to get your production back on track and having to get your store back together with an expanded work crew. We also see disrupted supply chain, as well as increased waste disposal fees due to all the perishable items that you lost during that power outage. Potential machine damages due to power surges when the power does inevitably come back on. And arguably the most important, a loss of customer trust due to the fact that you weren't there to be open to serve them during this time. The ability to be this beacon of light for your community lies in the hands of your next investment, because a greener, more profitable future is ahead of us. Today we've outlined for you the rising greenhouse gas emission regulations starting in California that are bound to start sweeping the rest of the country. We've also shown you increasing utility costs, as well as some of the grim reasons why the energy grid in the United States is starting to fall due to electrification, data center growth, and some political turmoil. However, we're excited to have given you 3 viable solutions that you can implement as soon as today, including small-scale on-site anaerobic digesters, emerging thermoelectric technology, and renewable microgrids. If we've shown you anything today, we hope it's that waiting for your city, state, or local government to take action to the power that your buildings and facilities are connected to is going to be too late, and that you have the power within your four walls to take charge. Which is why it's time to decide. Are you going to stay dependent or choose to power your own future? We asked the companies in this audience today to appoint a sustainability lead to investigate and explore some of the solutions we've outlined today in the next 90 days with budget allocated for the next fiscal year. So it's going to be up to you. Is your bottom line going to go green or red? And will your lights be off or on? Thank you so much for your time, and we're happy to answer any questions.
Team, great presentation and great job getting ahead of what was going to be my question on expected cost. I was wondering if you could shed some insight on what the expected useful life term of a standardized setup would be, and how often we would have to maintain or replace one of these setups for the micro grids.
It's about 20 years for the anaerobic digester, or 25 years. It doesn't need a ton of maintenance. The smart controller allows it to operate autonomously, and you'll need to, it'll have some replacement parts that you'll need to do, but not a ton of maintenance over the life of it. But 20 to 25 years is CAB Energy's expected lifespan for that equipment.
Thank you, well done. What's the time frame to process the waste? So when you're putting it in, how long can you expect to get something out of it?
It's about 14 to 28 days.
Okay, thank you, team.
Thank you.